Alright, so let's see how we're doing. Here we go. Warm up number 6. That's on the screen. We'll start off with number 1, and being that it's Monday, I'm going to go over it just to make sure we got this. Yes, it's a good review. Number 6 reads, problem number 1, simplify. Negative 1 plus 2x plus negative 3 plus y plus negative 4x minus 3y plus 5. So, first thing I asked you to do with these is to check for what? Addition throughout. Is that correct? Addition, 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 subtraction, and addition. That means I need to make a change right there. So what does that change? This becomes a positive. And what is the opposite of a 3y? Negative 3y. So I no longer use this, and everything else stays the same. Combine like terms. So I'm going to start with the constant. We have negative 1 and negative 3. What is negative 1 and negative 3? That's negative 4. And then I have a positive 5 over here, so 4 of these cancel 4 of those, and we're left with positive 1. So far, so good? Yes, Mr. Q. All right, good. Next, I'm going to go with x. I have positive 2x, and I have negative 4x. So that means 2 of these cancel 2 of those, and we're left with negative 2x. Are we doing good? Yes, Mr. Q. All right, good. Let's go with y. I have a positive 1y, and I have 3 negative y's. So what does that mean? That one of these cancels one of those, and we're left with negative 2y. Okay? Now, since we are in Algebra 2 now, this is what I need from you. Pay attention to this part. This week we're going to be practicing writing this in standard form. What does that mean, Mr. Q? First, you need to find out how many parts does it have. 1 part, 2 parts, 3 parts. What does that mean? Those are known as terms. Okay? How many terms? 3. We need to find out how many degrees each term has. How do we know that, Mr. Q? Well, you need to look for the variable and look for the exponent. If it has more than one variable on the part, you combine the exponents of the variable. I'm going to start with the y. Look at this. How many variables do you see? 1. What is the exponent? An invisible 1. So this is 1 degree. Next, I'm going to go to this one. Do you see the variable? Yes. What is the exponent? 1. So what is the degree on this one? 1. The last part. Do you see the variable? No, it doesn't have a variable. So if it doesn't have a variable, this is 0 degree. So what is standard form? To rearrange it from highest degree to lowest degree. So what is my highest degree? 1. But here we have 2 of them that have 1 degree. So which one do we put first? In alphabetical order. Which is the first one that comes up? X. So we write negative 2x, and then negative 2y, and at the end, plus 1. This is standard form. We're going to be practicing that all week. Okay? Number 2. Line down the equal sign. Can we simplify the left side? Yes, Mr. Q. So distribute the 3 here. That is 3x plus 3. Bring down the negative x. Now, one common mistake that some of you make, look up to the screen, is some of you don't distribute to both terms. Be careful with that, especially in the afternoon that some of you are tired and it's after lunch. So here it is. Next, I'm going to combine. Here's 3x, and here's minus 1x, and that leaves us with what? 2x. Bring down the plus 3. Can I simplify any more? No. Bring down the equal sign. Okay? Next, this side. Can I simplify? Yes. Distribute. 2 times x and 2 times negative 3. That is 2x minus 6. Here's the second common mistake. Look up to the screen. This negative is actually a negative 1. That means we need to distribute that to both of those terms. That means this is what? Negative 1x minus 4. That's the second most common mistake. Can we combine stuff? Yes. What is 2x minus 1x? X. What is negative 6 and negative 4? Negative 10. Negative 6, negative 4, negative 10. Okay. So, at that point, we need to get all variables to one side. Here's a positive x, so that means we subtract 1x, subtract 1x. That leaves us with x plus 3 equals negative 10. And last but not least, we do minus 3 minus 3. X equals negative 13. Let's go. Piece of cake, yes? Or how do they go? Like this? Yeah? Yeah? You guys all right? Yeah? You guys tired or what? Or is it too hot outside? Yeah? But now we're here. We're cool, right? Get it? We're cool. All right, here we go. Let's go to number 3. So for number 3, it looks like we have fractions. So what is our common denominator, people? 24. So we multiply the entire equation times 24. Distribute, distribute, distribute. That leaves us with negative 24 over 3x plus 48 over 4 greater than 96 over 24. Simplify. Negative 24 over 3, that's negative 8x. 48 divided by 4 is 12, greater than 96 divided by 24 is 4. So if I continue, what do I need to do? Minus 12 minus 12. You got negative 8x greater than negative 8. Last step, divide by negative 8, divide by negative 8. X is less than 1. Tell your neighbor why it flipped, please. Why did it flip? Yeah, because we multiplied or divide by a negative number at the end, okay? Tell me your fingers how come you are with the warm-up so far. It's a review from what we did last week, okay? Copy the agenda, please. Here we go. Agenda for today, warm-up number 6. Today we're looking at compound inequalities, and your home plate for tonight is only 8 problems for solving inequalities. Hurry up, hurry up, hurry up. Once again, reminder, don't copy the home plate where your notes are at or where your warm-up is at. Copy it in a separate sheet, please, because you need to turn this in when I ask you. Those of you that are watching on YouTube, if you want to follow along, here's an earpod code that you can advance the slides on your own, H7X84. All right, here's the home plate, and it reads, solve, graph, check, and write the solution and set notation. Now the instructions you don't have to write because I'm going to give you the instructions again right now when we go through the lesson. So let me zoom into number 1. Number 1, negative 1/2 x plus 2/3 less than or equal to 5/6. Number 2, 5 greater than negative 3x minus 8 over 2. Just put it in there. Number 3, negative 30 less than or equal to 7n plus 2 minus 11n. You're like, what? I know, right? Fun stuff, yeah? Number 4 and 5. Number 4 reads s plus 4 less than 1.5 or 3 plus s greater than or equal to 7. And number 5, 1 less than 3x minus 2, less than or equal to 10. All right, so those first 5 you're going to solve, and you're going to do the entire process that I'm going to show you in a little bit. Okay, we're going to revisit that. However, the last three are graphs. So I want you to draw 3 number lines, one for number 6, one for number 7, one for number 8. Here goes number 6. For number 6, I want you to circle right here where 6 is at, positive 6. It's an open circle or open point. And then you're going to shade everything to the left of positive 6. To the left of positive 6. There it is. Number 7. It's an open point between 2 and 3. You guys see that? Yes. And then you're going to shade everything to the right of that point. And number 8, if you notice, this one has 2 different arrows or 2 different graphs. The first one starts at -5. Notice down here, -5. But it's a solid point, And then it's shaded going towards the left, And then the other one on the same number line is +3, and it's an open point and shaded to the right, Let me zoom out. And that's a home plate for tonight. All right. So we're going to get started. You need a Cornell note. Now, on your Cornell notes, you don't need the Freyer model, that big rectangle that goes in the center. So don't draw that. If you already did, then that's fine. But you don't need that big rectangle because we're going to go straight into practice, okay, since we already have that from last week. We good? How about now? How about now? How about now? All right? And once again, this video is going to be uploaded on YouTube at the end of this class, so make sure if you miss anything, go to the YouTube channel. What is my YouTube channel? 23 Mr. Q. All right, here we go. So quick intro, remember that we introduced equations and inequalities with the scale? Yes. When it's balanced, it's an equation. When it's not balanced, it's a what? An inequality. Okay? So today we're going to continue with that idea. Here we go. Our objective for today, I can solve one-variable equations and inequalities. Once again, I can solve one-variable equations and inequalities. That goes at the bottom left of your notes. One-variable equations and inequalities. All right? What concept are we looking at today? One-variable equations and inequalities. What are we doing? We're still solving. Okay? So last week I gave you guys a Freyer model. Did I not give you this already? You don't need to copy this again. So what do we have? One-variable equations and inequalities. And what are they? 2 expressions that are equal or not equal to each other. Examples. We got all these 8 examples that I gave you. Once again, one-variable equations and inequalities. What do they have in common? That they are 2 expressions that are equal or not equal, but they only have what? One variable. And you're not copying this. You already have this. Yes? Okay. Yeah, last week we took notes on this in your Cornell notes. And I said, okay, if these are one-variable equations and inequalities, why are these not one-variable equations and inequalities? Tell your neighbor, please. Why are these 2 not one-variable equations and inequalities? Talk to your neighbor, please. All right, let's see. Jorge. Why is this one not a one-variable equation or inequality? Doesn't have the symbols, either the equal sign or the inequality symbol. That is correct. This is only an expression. How about this one, Luca? It has two variables. This is a two-variable equation. Right now we're only dealing with what? One variable. Remember that we did hashtag, and all that? Okay, so like I said, you already have these notes. You don't need them, okay? All right. What were the 4 steps that I asked you to copy? You don't have to copy them today. Simplify, isolate, plot, and check. Today we're going to be doing all 4 steps for everything we do today, okay? All right. So in the center of your Cornell notes, where you should have put the box, which today I asked you not to, I want you to write example Q. Example Q. Here we go. Example Q. And we got 9 greater than 2x plus 1. All right, let's do this one together, yes? All right, draw your line down the inequality symbol. And I'm going to switch to blue so I can do the first step. Can I simplify the left side? No. The right side? No. So what do I do to leave x by itself? What would be the first thing we do? Minus 1. We're left with 8 greater than 2x. Am I done leaving x by itself? No, I need to get rid of that 2. What do I do at the end? Divide by 2, divide by 2. And that leaves me with 4 greater than x. All right, let's graph this. Here we go. Start with 0. And then we're going to plot 4. 4 is about right there. So here goes the process. Last week I softly introduced graphing, but we only did it once. Today and this week we're going to be graphing a lot, so that's why I'm going to go over each part. Here it goes. Look at the inequality symbol. Does it have a little equal sign underneath? No, so that means this is going to be an open point. Open points. Okay. Now, since it's an inequality, we need to shade either to the right all the way or to the left all the way. How do we know where, Mr. Q? Well, test the number. The other number that I see here on the number line right now is what? 0. So I'm going to substitute here for x, 0. I bring down the 4 and the greater than. Let me read that. Is 4 greater than 0? Yeah, that is true. So if it's true, that means I'm going to shade towards the 0. Are we there so far? Okay. Next, we need to check. Check. I'm going to write my inequality again, this one right here, 9 greater than, but instead of x, I'm going to open a parentheses, plus 1. So according to what I see here, all this area that I shaded are solutions to the inequality. So I can test a number. So Kevin, what number would you like to test? 1. By looking at it, guys, is 1 part of this area here? Yeah, so that means it will work. Let's double check. Let's substitute 1 in here. And I'm going to mark it just to make sure. Here's 1. It looks like it is. So let's simplify this. 9 greater than 2 plus 1, because 2 times 1 is 2. So what is 2 plus 1? That's 3. Let's see. Is 9 greater than 3? Yes, and that's how you check. Last part of what I need for today's home plate is very important. Ready? I need the solution written in set notation. You're like, what does that mean, Mr. Q? Let me show you, for those of you that forgot. You started off with a little bracket like this, and that means solution set. That's what this symbol means. We started off with that. So it reads, solution set of the variable that you solved for. What was the variable? X. So I'm going to write X. And what does that mean? It means all solutions for X. When you write the variable in there, that means that it's going to be all solutions for X. Next, what do I write? A bar, like this. And what does that mean? Such that. Such that. Kind of like meaning, okay, the solution set for X, such that, which means as follows. And lastly, we do this. Look up. We take our inequality that we came up with at the end, and we write it here. We write 4 greater than X, and you close your solution set. Draw an arrow if you need to. In case you get lost, draw an arrow saying that that goes right there. And that's all the process that you're going to be doing tonight. Let's do another one. Ready? But here goes the process one more time. We solve for the variable. We graphed our solution. We checked our solution, and we wrote our solution set. And it reads solution set of all X values such that 4 is greater than X. All right. So another one, example super cute. Example super cute. I'll give you a head start for this one so you can see if you've got the process already. 5y plus 2 greater than or equal to negative 23 microjoules. All right? So I'll give you a head start. Let's see how you do with that one by yourself. Ready and go. All right, so let's see how we did. So, line down the inequality symbol. We can't simplify either side, so we started by doing what? Minus 2 minus 2. 5x greater than or equal to negative 25. So far so good, yes? Oh, 5y, yeah. I did that on purpose to see if you were paying attention. See? Pretty good, right? And last step. Now, do you guys see that if I make mistakes, what about you guys? You see what I'm saying? So I'm doing that on purpose, by the way. Divide by 5, divide by 5. We end up with y greater than or equal to negative 5. Now, somebody asked previously, they're like, Mr. Q, how come you didn't flip it at the end if we get a negative? Because we did not divide by a negative. We divided by a positive. So be careful with those. All right, let's graph this. Here's 0. Then I'm going to go to negative 5. Is it a open or closed point? Closed because it's got an equal sign, so it's a solid point. Next, I need to test a number. What number do we see other than negative 5? 0. So I'm going to substitute it in here. Is 0 greater than or equal to negative 5? Yes, that is true. So that means I'm going to shade towards 0. So, possible solutions. Tell your neighbor what are possible solutions for that one. Possible solutions. Yeah, so we can check it, yes? So we do 5 times y plus 2 greater than or equal to negative 23 microjoules. All right, Genesis, give us a number. 1. All right. So by looking at it, if I was to graph it, is 1 part of the solution? Yes. Well, let's check it. Substitute in here. So what is 5 times 1? 5 plus 2 greater than or equal to negative 23. 5 plus 2 is 7, greater than or equal to negative 23. Is 7 greater than or equal to negative 23? Yes, that is correct. So, what is the last thing we need to do? We already checked. What's the last thing? Solution set. So let's write the solution set. Solution set, which variable? y such that, and what is my solution? It's right here, so we write it here, y greater than or equal to -5, and close your set. Let's go. Let's go. Well, not yet. We're almost there. Show me your fingers how comfortable you are with these now. 5 4s, 5 4s, 5 4s, 5 4s. Okay, we just need practice, yes? All right. Now, let me show you an area that some of you struggle with. Comparing two numbers. So look up, please. Here it goes. Writing utensils down. You don't need to copy this. When I give you two numbers and I ask the question like here, look up like here, 0 and -5. You need to picture them on the number line in order to make a wise decision to see if it's true or not. Whenever you're comparing two numbers, check this out. Numbers on the right are greater than numbers on the left. So for example, let's say I said, okay guys, I have -10 and -2. Which one is bigger? The -2, because that, if you picture it here on the number line, that's more to the right. So here it goes. Let's say 0 is here. Where's -2? -2 is here. -10 is over here. So the one to the right is -2. That's why it's greater. That means -10 is less than -2. Okay, so think about it like that when you're comparing numbers. Okay, we good? All right, let's move on. So, let's crank it up a notch, shall we? Yes? Yeah, let's, imagine if I gave it like caramel macchiato. Yeah? An upside down caramel macchiato. Let's crank it up, yeah? Never mind. All right, writing utensils down, look up to the screen. Pay attention to this part. It's going to go fairly fast. To solve this, we need to do what? -1 -1. Yes? We end up with -6 less than x. To graph that, we start at 0. The other one is what? -6. Is it an open or closed point? Open, because it doesn't have an equal sign. And to graph it, I need to check 0 here. So -6 less than 0. Is that true? Yes, so we're going to graph towards 0. There it is. If I give you another one, such as that one, look at it. To solve this one, what do I do? -1 -1. So this cancels. We're left with x less than 1. So far, so good? To graph, here's the 0, here's the 1. It's an open point because it's got no equal sign, yes? And if I substitute 0 here, is 0 less than 1? Yes, so that means I'm going to shade towards 0. There it is. Okay? So we're fine up to right there. Today, we're going to work on combining or compound inequalities. What does that mean, Mr. Q? That we're going to look at inequalities that are 2 in 1. Now, I put some animation here so you guys can see it. Here it goes. So it can make sense to what I'm talking about over here. Look up to the screen. So I'm going to take this one, and I'm going to take this one, and I just combine both to make this one right here. This is what we call a compound inequality. We're going to be solving these today. You're like, what? I know, right? Exciting stuff, yeah? You're like, it's going a little bit too fast for you. I know, but it's more like a review, hopefully, yes? Copy this one, please, example 1. You don't have to copy the instructions. Basically, all it's saying is going through all the process, but copy -5 less than x plus 1 less than 2. -5 less than x plus 1 less than 2. Just copy that, and I'm going to go over it really quick, and I'll ask you to copy right out. Okay? Write your utensils down, look up to the screen. Here we go. Here goes the process. Look up to the screen. What is the first thing we do? Line down the inequality. Oh, there's another one. Here it is. Question, can we simplify the left side? No. Here, no. Here, no. To leave x by itself, what shall I do? minus 1, but I do that to all sides. We're left with negative 6 less than x less than 1. Copy that, please. You're like, what? I know, right? It's like Dragon Ball Z turning into something else, right? No? No dragon? No? Okay. All right, let's graph this. Now, hopefully you already have your material, so we're going to need 2 different colors aside from black to be graphing and not get confused with our graphs. Here we go. 0. I'm going to start with the color red. I'm going to do the first part, this, which is negative 6 less than x in red. So here we go. I'm going to start at negative 6. Is it an open or closed point? Open, because it doesn't have an equal sign. And then I need to test a point, so I'm going to test 0. So I'm going to substitute it in here. So let's see. 0 less than negative 6. Is negative 6 less than 0? Yeah, that is true. That means I'm going to shade towards 0 and beyond. There it is. I'm going to switch to green now, and I'm going to graph the second part of this compound. And we start at what? At 1. Here's 1. Does it have an equal sign? No, so that means it's an open point. And I'm going to test again with 0 to see if I shade towards 0. So substitute 0 for x. Is 0 less than 1? 0 less than 1? Yeah, that is true. That means I'm going to shade towards the 0 and beyond. And what do you guys notice now with these graphs? That now we have 2 graphs that are intersecting. You guys see that? So what does that tell us in regards to solutions? That the solutions are in between what? Negative 6 all the way to what? 1. So it could be any number in between. Let's check that. Check. Let's write negative 5 less than, we don't write the x, I'm going to leave it blank, plus 1 less than 2. So tell your neighbor a possible solution for that inequality. What would be a possible solution? All right, help us out, Justin. Possible solution. Negative 3. By looking at it, is negative 3 in this section? Yes, so let's try negative 3. Let's substitute it in here. So we got negative 5 less than, what is negative 3 plus 1? That's negative 2. Let's read this part first. Is negative 5 less than negative 2? Yes. Now bring down the other inequality sign and the 2. Is negative 2 less than positive 2? Yes. So that means it worked for all of them. Are we done? No. Solution set. Solution set. Which variable did we solve for? X, such that. What goes in here, Dominique? What goes in here? Our solution, which is right here. Which is?
Negative 6 is less than x, which is less than 1.
That is correct. Negative 6 less than x less than 1. Put a little asterisk here, and then send an arrow so that you remember that that goes right there. How we doing? See how everything came together now? Yeah? Show me where your fingers how come you are with these. 5 4s, 5 4s. Okay, let's do another one. I'm going to give you a head start on this next one to see if you can do this one by yourself. Y'all ready? Yes, Mr. Q, we love these. All right, good. All right, example number 2, we got negative 9 less than x minus 10 less than negative 5. See how you do with that one? Ready and go. All right, let's see how we did. Should have done line down, line down. We can't simplify anything, so the next step is to start solving. So you should have added 10, added 10, added 10 to all sides. This cancels. We're left with 1 less than x less than 5. Hands if you got that. Yeah, let's go. You guys remind me of me when I was in kindergarten. All right, so let's be nice. Here we go. 0. All right, I'm going to do the first part in red. Here we go. This part. That's 1. Open or close point? Open. I'm going to test 0. Substitute it in here. Is 1 less than 0? Nope. 1 is not less than 0, so I'm going to shade, instead of shading towards 0, I'm going to shade in the opposite direction. Opposite direction. Next, the second part in green. X less than 5. So 5, let's say it's over here. It's also an open point. I'm going to test 0 again. Is 0 less than 5? Yes, that is true. So that means I'm going to shade towards 0. And what do you guys notice? They overlap. Tell your neighbor possible solutions for this inequality. Possible solutions. And let's check it. Let's check. Let's see. Alyssa, give us a possible solution. 2. Does it look like it falls in between? Yes. So let's substitute that in here, and let's see. -9 less than -8. Is that true? Yeah, -9 is less than -8. How about -8 less than -5? Yes, that is also true, and we're done with checking. And our solution set, let's see, help me with a solution set, Giovanni. Solution set what? X such that (1) less than x less than 5. Let's go. We got this, yes? Compound inequalities, we good? All right. Now, let's crank it up a notch, yeah? Oh, yes. Don't copy this, look up to the screen. But look at it. What would be the first thing you do, everyone? Add 1, add 1, add 1, and at the end divide by 3, yes? Look at this one. First thing we do. -5, -5, -5, and at the end, divide by 3. We got this, yes? Copy this one, example 5. It reads 8 plus t greater than or equal to 7, or 8 plus t less than 2. 8 plus t greater than or equal to 7, or 8 plus t less than 2. You're like, Mr. Q, this looks weird. I know, right? Because of the word in between the two inequalities. All right? So let's do this one together. Y'all ready? Let's start with red. I'm going to do this one on the left. Let's do it in red. Here we go. Line down the inequality symbol. So to solve this for t, what would I do to leave t by itself? -8, -8, and that leaves us with t greater than or equal to -1. Okay, bring down the word or, and I'm going to switch to blue, and I'm going to do the other one. Line down the inequality symbol, and once again, what do I do to solve for t? -8, -8. T is less than -6. All right, so let's graph this. You're like, that wasn't that bad, Mr. Q. I know, right? Here's 0. And I'm going to start with the first one, -1. -1 is right here. Question, is that an open or closed point? Closed, because it has a little equal sign. So yeah, a closed point, solid point. So, what are we going to test to see which direction? The 0, yes? So instead of t, I write 0 greater than or equal to -1. Is 0 greater than or equal to -1? Yes, so I'm going to shade towards 0. Towards 0. And yes, this is true. And we already checked, by the way. For these or, that's going to be our check, okay? So with blue, -6. -6 is right there. Is it an open or closed point? Open, because it doesn't have an equal sign. And once again, I'm going to test which number? 0. So is 0 less than -6? No, that is false. So am I going to shade towards 0? No, I'm going to shade away. Thank you, Maddie. What do you guys notice with these? They don't intersect. That's why these are known as or, because the solutions are what? This or that. Yes? Like number 8? Yeah, this is like number 8. Yeah. So check this out. Are we done? No. Like I said, this is already our check right here. We just need to worry about the solution set. What variable did we solve for? T, such that, and check this out, this is our solution that goes inside the solution set. So I write what? T greater than or equal to -1 or T less than -6. Whew, let's go. Some of you fingers how up you are so far with compounds? 4, 5, 4, 5, 4, 5. Some of you have weird fingers. 5, 4, 5, 4s. Some of you need a manicure, right? A mani, yeah? All right, and last part. Now check this out. The other ones that I was going to share with you are pretty much the same, this or that, and you just solve each one independently, graph, and so on and so forth. But I want to get to this one. Copy this one, number 9. It's a number line, and then we have one open point at -2, and another open point between 4 and 6, and this one, they're shading in between those two. All right? So for the graphs, tonight you have 3 graphs. For the graphs, I only want you to write me an inequality from the graph. Now let me show you how to write an inequality for this one. I use this dividing point, I use the second dividing point, and then I make up a variable for the solution set. So I'm just going to say x. Whenever you have graphs that intersect like this, these are known as and, the arrows are always pointing to the left. If these were solid, what would we write underneath? An equal sign, is that correct? But they're not. And all we have to do at the end, we just do solution set of x, such that, and that. Very simple, straightforward. So for those 3 that I gave you for our own play, I just want to see how you do writing inequalities, just looking at the graph and see if it makes sense. And we'll talk about it tomorrow as we go through, okay? And we'll stop right there, yes? And once again, those of you that are watching online and you follow along on the EarPod, you can actually see some more examples of these and do some more practice. I'm going to stop the video and have a good one, guys, and I'll talk to you guys later. Peace.